Okay, afternoon everyone. Welcome to the Sleepy Go Bye-Bye after lunchtime slot. I'll try and keep everyone awake. I was actually just doing the introduction this morning. I was trying to count up my security talks. I'm either at 5 or 6, but I've kind of lost count. It's either 5 or 6, but it's something along those lines. But anyway, thanks very much for having me back again. The talk today is about, as it says, cloudy clusters catastrophe. Essentially, a lot of this is going to talk about a product called Kubernetes. I got involved with this a couple of years ago, the same way I do with anything, which is a customer said to the company I work for, we want you to review the security of our Kubernetes environment. And someone said, oh, you know about Docker. And that's the same thing. Go and talk to them. So I went and read what the hell it was before I turned up at the meeting. Since then, it's kind of taken off in terms of popularity. I was at a thing called KubeCon in Copenhagen a couple of weeks ago, and they had 4,300 people there. Up from 1,300 the previous year. And pretty much every single large tech company had a kind of huge, very impressive and extremely expensive stand. So it's fair to say this stuff's taken off. And because if people start using a technology, security people have to start breaking into it, and we have to start securing it. So hopefully this talk will kind of go through a bit of what you can and can't do, and what's good to do and what's not good to do. And also we'll try and do some demos and break in some clusters while we're at it. So, the very brief about me, I've been in IT information security now for 18 years. I'm a managing consultant for a company called NCC, who you may have heard of. We do security tests and other stuff. I'm also a contributor at Security Stack Exchange. Has everyone heard of Security Stack Exchange? Yeah, show of hand. Couple people? Yeah, cool. Excellent. So if you haven't heard about it, it is a smaller and friendlier version of Stack Overflow. If you have a security question, it's a good place to go and ask. We have some reasonably nice people. And also if you want to answer questions about security, it's a good place to go. The other thing I'll mention briefly is I'm a contributing author to the CIS Docker and Kubernetes standards. So a couple of years ago when I got involved in this, one of the big problems with the new technology is there was no documentation, right? There's the odd blog post, maybe someone had done a video about something, but really there was very little information. So these standards got started up, and they're actually not a bad place if you're interested in kind of like working on this stuff. You can kind of go and read the standards, and they get kept reasonably up to date. Because I am a pen tester, I get to work from home a lot, and as we're doing a nautical theme, you'll notice the nautical theme. This is the Hebridean Princess going down the loch I live on, this is Loch Goilhead in the Scottish Highlands. It looks great when it's not raining and when the midges aren't out, so that's about 2 weeks a year. The first thing people say to me when I say I live out in the middle of nowhere is, what's the internet like? And as of this year, I can proudly say, not too bad. That's my internet access at home. It wasn't very cheap, but it is very nice. And now I can live from home and actually have a civilized life. So, let's go on to that. Let's talk about the talk. What we're going to talk about. Container 101. So, containers underlie all of the technology I'm going to talk to you about today. Actually, containers underlie a lot of technology that gets used. Google have stated for a long time now they run all their workloads in containers. So, it's worth having a quick chat about what the heck are these container things and how do they work. We'll cover that pretty quickly. We're going to talk about the Kubernetes architecture. So, if you're trying to break into a product or you're trying to secure a product, the best thing to start off with is, how does this work? What are the components that make it up? And what do they do? Because really, you can't really understand how to secure something unless you actually understand how it works. So it's good to have a little bit of chat about that. We're going to talk about deployment options very briefly, because this surprised me when I started looking at it, so it's worth knowing about. Threat model, how can we break into these things? What type of people might want to do that? And how are they going to do it? What are the actual exploits we can exploit to try and break into clusters? And then, because I shouldn't be a bad security person and just say, hey, you can break this stuff, I'll actually talk about here's how you fix some of it as well. And here's some of the things, if you're deploying this stuff or you're actually interested in making use of it, some things you should make sure of before you actually roll into production. So what's a container? That's kind of the first thing to start off with, and it gets a bit confusing. Some people think of containers like virtual machines, and they're not. So if a container essentially is, the best way to think about it is it's a way of packaging an application and all its dependencies, its libraries, and everything you need to make it run into a portable format that you can move from place to place really easily. And that's the best way to think about it. So you can get anything, a WordPress site, a ASP.NET site, a Java, whatever you like, put it into a bundle, and you can run it in a variety of different places. You can run it in AWS, you can run it in on-premises, and it'll all just work. So it gets rid of the problem you get in IT where a developer writes something, works fine on his laptop, puts it into production, there's a different dependency, there's a different version of a library, suddenly it doesn't work. Containers, at least theoretically, should get rid of that problem and make it all go away. And that's one of the reasons why it's so popular, because it solves a lot of problems. if you think about it, I got kind of diagram to, this is why companies like it. So in the old world of virtual machines or hardware, over here on your left, you'd have essentially one application on top of a virtual machine operating system, or maybe a real world, maybe a bare metal server, but you'd have one app per OS image, right? In container land, you don't do it like that anymore. You have lots and lots of little containers running across a single operating system image. And the reason people like that is because it saves them money, basically. If you roll out your systems in the cloud and you use EC2 instances, if your EC2 instance is only used 10% of the time, you pay for the full instance, for whatever you've bought. So it's in your interest to make as much use of anything you roll out, because as Paco said in his keynote this morning, time is money in cloud. So the more use you can make of your resources, the more essentially bang for buck you get. So containers are great for that because they're nice and small and they can sit happily next to each other on a single operating system image without messing with each other. So that's why companies like this stuff, because essentially they get more for less. That's always a selling point. So where does Docker come in? Containers are not new. Containers are in fact a really old technology. You can go back to the 1980s in Chirut, and from then you can go through things like BSD jail, Solaris zones, but they only really became popular when Docker, or really popular when Docker turned up on the scene about 5 years ago now. Docker essentially just makes it nice and easy. It makes it friendly. It makes it easy to run containers, and it provides. I'll show you kind of on a diagram. This thing over here on the right, which is a registry, this is why Docker is so popular, in my opinion anyway. It's an app store. So if you think about your mobile phone, you can say, I want Telegram, I want WhatsApp, I want anything. And you don't have to worry about how it runs, how it installs, or anything like that. You just say, give me that. That essentially is the app store for containers. You can say, give me a WordPress site, give me an Oracle database, give me a MySQL database, give me pretty much anything. There are hundreds and thousands of images available for you to pull and run. So that ability to instantly run something and get it running quickly was really attractive. And I think that's why Docker, it made things nice and easy, right? Before you could do containers, but it was kind of messy and a bit hard and a bit difficult to do. Docker made it, run that command, Docker run, it goes and sorts itself out, it pulls the image down onto a machine, starts a container, and away you go. And suddenly it starts working. One piece of terminology that confused me, so I'll mention it. An image essentially is like the kind of template that you build from, and a container is a running version of that image. So if you kind of get those two terms right, containers is like a running version of an image, but the image is actually like the template. And you get the template from the registry. But it just made it easy and nice, and that's why people like it. So what's Kubernetes? We're doing lots of definitions to start with. Kubernetes, one of the reasons why for all the nautical images, by the way, is they love like nautical imagery for everything, container related. Kubernetes is Greek for steersman. So it's all nautical images. I'm really happy to see. I was thinking that we've got the images on the banner for the conference as well, so it all fits in quite nicely. Complete coincidence, but you know. This is what they call it. An open source system for automating, big long definition. What it is essentially is Docker lets you run one machine, right? So I can run containers on one machine. What if I've got 30 machines? What if I've got 3,000 machines? And I want my containers to move around between huge numbers of groups of VMs seamlessly. So I can say, hey, I just run a Super Bowl ad, and now I need 20 more instances of that container. Kubernetes, you can just say, scale that up. And it says, oh, what machines haven't got a lot of load on them? Right, I'll go and shove it on this one, this one, and this one. And it handles that all for you. So it basically makes you able to scale and deploy complex applications easily, at least in theory. And that's again why it's becoming so popular, is it takes away a lot of the complexity and lets a developer just say, hey, I need an application, it's got these 5 components, go and run it, and Kubernetes goes, boom, okay, there you go, you've got it all running. Now, because I am maybe not quite sensible, I'm going to try and do a demo. So, what have we got? The way Kubernetes works is you get a YAML file. Everything in Kubernetes land is YAML. If you do anything with containers, you'll end up writing YAML and probably hating it. This is a YAML file. It describes essentially an application with several different components. There's some Redis servers in there. There's some various different types. There's a front-end server, a back-end server, various bits and pieces. It all consists of one YAML file. Now, what I should be able to do is kubectl is the command you use for basically all this stuff for managing. Example of YAML. Right, that's just done that. That's created that. So I should now be able to say kubectl get svc. That's created some new services for me. So now I've got some Redis servers, I've got a front-end server, and here you can see I've got a kind of a port 32478. So now if I go in here and do that. 32, so 32, 78. Cool. That's my web app, right? And I can type messages into it. It's a little guest book. And what I can do, should also be able to do, if I go to knode 2, that's the other node in the cluster, right? So I've got 3 nodes in my cluster. So this thing has replicated the state across all the different nodes. So my message from I typed in on node 1 is turned up on node 2. And my message that I can type in on node 2 will turn up on node 1 and node 3. I don't need to know how that set up its containers. I don't need to know where they were. I don't need to know how it configured them. It just worked because I ran the YAML. And when I'm finished with all this, I can just say kubectl delete. And it goes and wipes it all out for me. And my cluster is back the way it was before I started. And that's why people like Kubernetes, right? That's why developers like it. Because I'm a developer, that's really super simple and kind of useful. Cool, and that worked. Didn't work, so I don't need the video. Put your background, where did this all come from? Google started this in 2014. They basically had an internal thing called Borg. They wanted to have an open source version that they could share with the world and get people to use. And they came up with Kubernetes. Now, basically, it's part of the thing called the Cloud Native Computing Foundation. So the Cloud Native Computing Foundation is all the big cloud companies got together and said, let's all do some cool tech. And it's seeing very rapid development. You get one release every 3 months, which is hugely painful as a security person because they change the goalpost every 3 months or so. So you'll come up with some guidance and say, do all of this, then a new version comes out, and it's like, oh, actually, no, do all of this instead. Rapid adoption. So, as I said, I got into this 2 years ago, just about 2 years ago now. Since then, we're seeing a lot of companies you wouldn't traditionally regard as kind of early movers. We're seeing banks. Monzo have been extremely public. That if you've got a Monzo card, all their stuff runs on Kubernetes. They're very, very kind of early adopters. You're also seeing things like the public sector getting involved in this. You're seeing a lot of large organizations. It's getting really rapid adoption. If you go into kind of corporate IT, you will, I guess, run across this stuff. And yeah, and that's what the Cloud Native Computing Foundation, that's their platinum members. The interesting thing, there's JD.com. Ever heard of JD.com? Biggest retailer in China, not much smaller than Amazon in terms of size and scale. Absolutely huge company, but if you're not in China, you never heard of them. But they're platinum sponsors of the Cloud Native Computing Foundation. But basically, you've got all the kind of big names in tech are there. Pretty much they're all involved. So how does this work? That's kind of the background. Let's talk about how it all works, how the architecture actually hangs together. Some terminology very briefly. A pod is a group of containers. It's like a pod of whales. I'm guessing that's the analogy they're going for. But basically, it's a group of containers that work together. So like a pod of whales that hang around together. A service is what sits in front of all the pods. So you shouldn't need to know what pods do. It all gets hidden from you. You get to see services. So when I connected to a service there, that was what you could see. And a node is just a node in the cluster. How does it work? That's kind of important. So now we're going to try and break into this thing. First thing for us to do is understand how does it actually work? How does it hang together? This is what it actually is made up of. This is the reality of what Kubernetes is. The API server is just an HTTP API, and that manages everything in the cluster. That's the critical component. You want to break into a cluster, you start there, because that's the key. Everything else goes through that. However, it tends to be the best defended bit because everyone worked out that that was the most important part. Up the top, we've got a thing called etcd. etcd is a key value store. So Kubernetes clusters are stateless. They don't know anything. You take one down, it doesn't know what and bring it back up. Unless it can connect to its database, it doesn't really know anything about itself. That's super interesting because all the secrets live there. So every secret that someone puts in, the developer puts in a password, stores it in a secret object inside the cluster, it lives in that database. So if you can pull out the database, you're going to have a good time. And down here at the bottom is the other really important one, is a thing called the kubelet. The kubelet essentially manages all the containers. So it runs Docker. If you can control the kubelet, you can tell Docker to do things for you, like give me root access to that container. And it'll say, yes, of course. So the kubelet is super important as well. This Docker is kind of involved in there. Put container engine. This is getting really complicated. It used to just be Docker. So I started doing this presentation 8-9 months ago. It was just Docker, really. Now you could have Docker, you could have Cryo, you could have Rocket, you could have gvisor, you could have a whole load of different, lots of people bring up products to replace that bit there, but at the moment it's generally Docker. And networking. Kubernetes networking, if you get involved in this stuff, is really weird. One of the promises, the way it works, is it provides a flat network. So all your applications can see all your other applications over a flat network, regardless of what the actual underlying network looks like. So you could have things on different clouds. You could have one node in AWS and one in Azure. But as far as the applications are concerned, they're going to see a flat network, which is really important because it makes it easy for them to talk to each other. It also is kind of important because it means that network traffic can be hidden from the underlying infrastructure. So if you're trying to detect what's going on, you might not see it because it's all hidden in an overlay network. And the other weird thing is Kubernetes doesn't do this for you. You have to use third-party plugins. So they've got some fun names like Weave and Calico and Flannel and lots of Romana, and there's a wide variety of odd things. Mainly I tend to see Weave and Calico these days. But networking is interesting. How are we doing? Okay. And deployment options. This surprised the hell out of me when I started looking at stuff. Someone will say to me, oh, what's Kubernetes security like? And I say, well, which deployment do you mean? You get lots of commercial companies have their own deployment, their own distribution. This is a word cloud I did. There's an official list maintained. It was at 60-something when I started looking at this. It's at 70-something now. There are 70-something different either commercial or open source projects. And each one of them will deploy it in a different way and in a different style with different default settings. So it's kind of difficult to work out exactly what the defaults are because you need to know what the defaults are for each 70 options. It gets a bit confusing and complicated. Some of those are more popular than others, but there are loads. So where does the cloud come in? I put cloud at the start of this talk title, and I haven't really mentioned the cloud yet. Well, lots and lots of people run these things in the cloud. The cloud is becoming by far and away the most common place we see applications run. If I would go back 5 years ago when I was testing, we would be surprised, or not surprised, but it'd be like 10-20% of deployments would be cloud-based. Now it's way over half. We just assume it's going to be AWS or Azure or something, unless we hear otherwise. And people are rolling a lot of these container stuff out on top of clouds as well. Every cloud provider has a funny acronym for their Kubernetes service. Google have GKE for their Google Container Engine because GCE was taken. Microsoft have got several, ACS or AKS. Amazon have got EKS, which isn't actually out yet, but will be real soon now. And Red Hat have got something called the OpenShift Cloud Platform. So they've got one as well. But there's lots of different ones. Each one of those has its own idea about how to deploy as well. So it kind of matters. And we'll talk a bit about how where you're running on a cloud, you can actually get compromise out of that as well. So probably the most important part of this entire talk, if you are thinking about deploying this stuff, is I just told you there are 70-something different ways of deploying it. One of the things that surprised me a lot when I was looking into this technology was the fact that everyone has a different idea of what a secure default looks like. And some of them are really surprising from a security. I'm going to show you some like boneheaded mistakes that people have made or do make. I've seen every single one of these in a live production default settings from major cloud providers or major distribution providers. This isn't just theoretical stuff that I went in and artfully broke something to make it easy to hack into. This is stuff I've seen in real. Either I've seen it in real and I've done it on pen test and compromised people's systems, or this is real. I've seen this in default deployment options. So if you are going to deploy this is something you're interested in, getting this stuff right is absolutely critically important, because if you don't do it before you go live, this is quite a complex technology. No one wants to go around and change settings after they've gone live and everything is running. Do it before you get that done right. If anyone's, when you think about it, the security industry is still dealing with the aftermath of people saying admin as a default credential, like 20 years after that started being a thing. If you make a mess of this, it'll probably still be hanging around for years. So, threat model. How do people break into these things? There's 3 different threat models I want to cover as part of this talk. We've got external attackers. Our external attackers are people who are coming from outside of the cluster, and they're going to try and break in. So someone's sitting on the internet, or they're sitting on the corporate network. They want to try and compromise the cluster. We've got our attackers with access to a single container. So these are clustered systems. Some of the clusters can be huge. There was a presentation at KubeCon where there were people saying they had multi-thousand node clusters. So if I'm an attacker and I get into any one container, can I then take out the entire cluster? Can I become a cluster admin just based on having got that access? We're seeing this as kind of a thing that customers are asking for. They're saying, take the position of get one container. What can you do? And there's some interesting things to know. And then users. So this is a multi-user system. You've got lots of different users, lots of different, potentially you don't want to give every single one of your developers cluster admin access. I don't know why, but you might want to restrict that. So there's some things to know about there as well. But let's get to the fun bit. Let's start seeing how we're hacking it. Right, external attackers. I'm an external attacker. I've got a new network system to go and attack. What do? I port scan it. You start off with a port scan. You always start off with a port scan. If you port scan a Kubernetes cluster, it looks a bit like this. You've got a number. I mean, I don't know any other pen testers in the room. There's at least a couple. When I see something like that, I go, oh, good, I've got something to play with. Because there's lots of different things to attack, lots of different services. We've got etcd on 2379. We've got cAdvisor. I'll talk about that in a second. We've got the HTTPI server. They keep changing what port that runs on, so it could be a variety. 8080 is very interesting, but you can see in the name, this is the official name of it, is the Insecure API server. So you'd hope you'd never, ever, ever see that. I have seen that, either on either bound to localhost, which isn't too bad. I have seen it bound to internal cluster networks. So if you were on the network, you just literally went to port 8080 and said, oh, my cluster. But that's going away. Luckily, they have actually kind of gotten on that one. That one's going away. Later versions are deprecating that eventually. The kubelet runs on a couple of ports, 10.250 and 255. And then the network plugins, they have their own services as well, but that depends on which one you're running. As a brief aside, obviously, if you're an external internet-based attacker, has everyone heard of Shodan? Everyone heard of Shodan? Yes. Okay. So Shodan is super cool. If you haven't heard of it, it's like Google for network services. The good thing I found about Shodan is it was a while since I'd last looked at it, and I looked at it again this year. They used to only scan like a couple of ports, like small numbers. They started scanning loads of additional ports now, which is fantastic because you can find all sorts of fun stuff. One of the things you can find is etcd servers. There are 1,800, or where when I did this, 1,874 etcd servers running available through Shodan. What's interesting is the way that etcd does its authentication is it uses client certificates, right? So with client certificate authentication, if it's working, if it's an authenticated port, you wouldn't get a response back from the server. The fact that all these things on the right here have told me things like, oh, I'm running on an unencrypted port here, http:// not s, says to me these things don't have authentication turned on. Now, I'm a good ethical hacker, and therefore I didn't go and scan around any of these servers. Luckily for me, another researcher, who obviously doesn't have that concern, decided to, and downloaded all the databases. When they downloaded all the databases, what they found was they didn't even know that this was used for Kubernetes at the time, but they downloaded all the databases and grepped through them, and they found tons of keys and passwords and various other things. So it's fairly likely that at least some of these are people's Kubernetes clusters sitting on the internet, and that's the database. And we'll see exactly how easy it is to go from that to cluster compromise later on in the talk. But it was the fact that, yeah, all these ports are kind of exposed, and it's kind of very easy to find them now. Even the obscure ones, you don't even have to port scan yourself. You don't have to run up a mass scan box. You can just go to Shodan and say, hey, Shodan, what do I need to do?
It's now 2,230, by the way.
Right, go 2,200, that's an extra 500. The problem's not getting better, it's getting worse. Fantastic, that was a couple of months ago, so that's interesting. Okay, it's going the wrong way, brilliant. So yeah, so you can find some other stuff. Kubernetes does some, this is first of several weird things it does, or it was weird to me. So there's a thing called cAdvisor, which looks a bit like this. cAdvisor is just like a management information service. But it tells you a bit of stuff, like it tells you what's running, it tells you different versions of different processes, all this sort of fun stuff. It's unauthenticated. It's always unauthenticated. It can't be authenticated. There is no authenticated option. So if it's turned on, it's sitting there. This won't get you to this won't compromise a cluster, but it kind of, it tells you you're running it, you've found a Kubernetes cluster to play with, and it kind of gives you various pieces of information. So nice, but not really compromised material. That again is going away. The Kubernetes people have kind of woken up a little bit, and as I think it's getting deprecated in the current version and will be removed in some later version. But it's kind of interesting, but not super interesting. Attacking the kubelet, this is more fun. So when I said before, the kubelet manages all the containers. So it has the ability to go and look and see what all the containers do. And there's two different ports. There is a read-only port, which is 10.255, and then a read-write port, which is 10.250. If you get the read-only port, let's go into another tab so I don't lose that. Hey. Firefox does a nice job of formatting this stuff. This is again is unauthenticated. So if you find this port on a job, you find you're reviewing a cluster, you find this port, this is always unauthenticated. It can't be authenticated, and again, it's used for management stuff. And I find it's turned on most of the ones I've looked at, so it's almost there. You can't get code execution with it, but what you can do is it's an HTTP API, so you can kind of browse around. And this is just a list of all. Remember I talked about pods. So this is a list of all the pods running on this node. What is interesting, probably the most interesting thing from our perspective as kind of potential attackers. Where did that go? Okay, is one of the pods running on this is the API server. So the way it tends to work is the API server actually runs as a container. And what's interesting about that is it tells us some cool stuff. It tells us, this is the command line. The way it works is all the configuration is passed as command line parameters. It tells us every single piece of configuration for that cluster, unauthenticated. So you can get all that kind of good information. And it tells you things like what IP addresses things are on, what the cluster IP addresses are. This is useful information if you're an attacker. The ones that are especially useful or can be especially useful, you get things like that. That is the private key that's used to authenticate all communications with the API server. So obviously, if I'm an attacker and I can get a copy of that key file, I can then generate my own authentication requests and then sign it with that, and I can actually get access to the cluster. So that's kind of interesting because it's just, again, it's more information disclosure. If you're a pen tester, this sort of stuff is brilliant because it gives you a whole lot of other things to go and think about. And absolutely, if you're running a cluster, you should turn this off because why give people this kind of information for free? What's more interesting is if you go for the read-write port. So the read-write port on 10.250 is kind of interesting. Let's see if we do this. So, where are we? That's the one. Right. So, because these things are HTTP APIs, you can just attack them with curl, which is really nice because curl is running on just pretty much everything. So curl is a really good way of attacking things. What I've got here is I've got a post request, and I'm going to go to 10.250 over here. And then what I've got is I've said, right, okay, remember that API server pod that we just looked at on the other screen? Hit that and hit the API server, and then -d, and then just do command cat, that key file we found before. So again, you would hope that this would be, and this can be authenticated. The interesting thing is, in the dim and distant past of Kubernetes 18 months ago, there was no authentication option for this. Like, there was no way to actually have it authenticated, so every cluster had to have it unauthenticated. Now, it is available, but not all clusters do it. So you will still see clusters with this. And if you can do that, you should be able to do that. And there you go. There's my RSA private key. And that essentially is a private key that I can then use to create new certificates and create new users, because it uses client certificate authentication. So I can use that key to generate new users inside the cluster with cluster admin rights. And basically, that's my cluster at that point. So literally, if you find that port and they haven't locked it down, then yeah, curl is your friend. You can run through, if I clear, you can do, actually, very ambitious. I'm going to try and actually do it without actually what I've saved. Actually, this may be a bit too ambitious. Yeah, you can do that, which jumps out all the pods. So you don't even need to go into the browser and muck about. You can basically do one curl request to say, tell me all the running pods. If you find the API server, just do another curl request to say, give me the key, because you know where it is, because it's in a predictable location. So curl is your friend if you're hacking Kubernetes. Demo's done. Okay, so that's some of the stuff we can do from the outside world, right? So if you can get to some of these ports, you can pretty much compromise a cluster if they haven't put authentication on. So that's kind of nice and kind of handy. If you get a compromised container, right? So I've got access to a single container. Maybe they're running a PHP web app that's got some form of remote code execution. Maybe you're running some kind of application that's got some kind of vulnerability that gives me access to just that container. How easy is it going to be for me to get full access to the cluster? Well, you get container file system access. So obviously I've got access to the one container that I've compromised. You get an internal network position. So if you're running Kubernetes in the cloud, most people will firewall stuff off. Obviously those 2,000, whatever it is, people haven't firewalled their etcds, but most people will firewall from the internet. Once you're on the internal container network, most people don't firewall access, so you got access to a lot more services. And also kernel attacks. So one of the key points about containers is all of the containers on the system run against the same Linux kernel or Windows kernel if you're running Windows containers. If you've got some way of compromising Linux kernel, some sort of privilege escalation, you might be able to use that. It's not actually as easy as, a lot of people will say containers don't contain, you can always break out. No, that's not necessarily true. It's possible, but it's not definite. But this leads me on to the weirdest thing that I ever found when I started looking at Kubernetes. This is by far and away the oddest decision that I've seen that they made. they have a thing called a service account token. And the way that works is, every time you run a new container, Kubernetes says, you might want to talk to my API. So what I'm going to do here is I'm going to give you a token that lets you talk to the API, in case you want to do that. However, if you don't turn on a thing called RBAC, which is their access control system, every single one of those tokens is a cluster admin. So you end up with a situation that looks a bit like this. If I do kubectl, great, what's F? Well, imaginatively, we call it bad container. Okay, so I'm now inside my little bad container. This is some app that I've compromised. If I then do kubectl get PO, it just works. If I do kubectl get PO -n kubesystem, that works too. I'm a cluster admin. It all just did it for me. I didn't do any special magic with that container. That's literally just an Alpine Linux container with the kubectl binary downloaded into it. And that's all. What it does is very, very handy. It sets some environment variables as part of the spin-up process. It tells you where to find the API server, which is useful. And the kubectl knows about that. So kubectl will read environment variables and say, hey, do you know where to find the API server? And it says, yeah, you go there. And then it'll go into run secrets. Where are we? Kubernetes IO service account. No. Yeah, then it goes in there. And this is the location it mounted in. So I'll put that at the top. And that's the token that we talked about. So basically what it does is it looks in that default location. It says, can I find a file called token? And it says, yes, okay, present that when you try and authenticate. And by default, unless someone has changed something, that will work. And if they haven't turned on RBAC, it will be cluster admin. So basically, this caused a lot of surprise. There was a B-side San Francisco ran their CTF last year, not this year, last year, in a Kubernetes cluster. And they didn't know about this problem. So someone got the first flag on the CTF, realized they were in a container, went, I wonder, and got all the other flags just from that one point. So, no, I'm cluster admin, great, I'll go and get all the other flags. Ended the CTF really quickly. But, hey, that's what CTFs are all about. Finding cool ways of doing these things. Yeah, so that really surprised me as a piece of default behavior. We're talking about secure defaults, right? As a secure default, that one sucks. Because it means that the default is that everyone's got cluster admin unless you do otherwise. More modern clusters, again, not everyone's deployed RBAC yet. So RBAC is the thing that protects from this, and not every cluster has deployed this. So it's fair to say that you might see that in live. But yeah, service accounts were super weird. I don't know how that happened. That worked, don't need that. Okay, and etcd. So we talked about etcd, and we've got these 2,000 odd servers that we might be able to attack. So the question is, how easy would it be for me to get from using etcd to actually be able to compromise the whole cluster, right? That's the next question we have. And one of the things with all these hacks is none of this stuff, as you might have noticed, is exactly elite. This isn't super complex stuff. I actually had one of the pen testers who I did some training for saying it was really boring. They'd used this stuff on a test and it worked. And they were like, really? Didn't feel very kind of impressed with themselves. They had done what they needed to do and it was like 10 in the morning and that was them done. But if you've got etcd, okay, cool. So what you can do with etcd is it's got kind of cool little control program. They all seem to have something CTL. Like every single one of the programs in this realm seems to be like something like kubectl, etcd-ctl, it's like a kind of thing. But anyway, you can just basically point it at one of those servers on the line and you can say that to it. And it'll dump out every single key that it knows about. And it'll say, these are all the things I'm aware of that are in my database. And what we can do is if you go up through this list, where are we? Here we go. You'll notice there's a whole lot of things with the nice word secrets in there. Now, if I'm an attacker, right, and I see something that says, hey, there's some secrets in here, guess where I'm going to go and look? I'm going to look for things in secrets. And interestingly, these are the tokens. Those tokens we were talking about before. It turns out those all live in etcd. So what you can do is you can do clear. You can then do go and get one of those, right? And it'll just dump out. And you see down here, we've got this token file. And that's just a base 64 encoded version of that token file that we had in there in the previous environment. So what you can then clear for this, because this will be big, and then we do curl. Where are we? There we go. And what I've done there is I've just base 64 decoded it, and then shoved it as the authorization header in a web request. So that's just saying, all that's doing is saying curl authorization bearer, decode that token, and then just punt it at the API server, and that's the main API server there. If I do that, it worked, right? So it's authenticated me. So if I get etcd access, all I need to do, download some tokens, base64 decode them, find the API server, and then do another curl request. And that's me. And again, if they haven't turned R back on, I'm cluster admin at this point. And that's game over with that cluster. So again, that one can be a bit painful. And as we've seen, there's lots of people running that stuff on the internet. So yeah, they're probably going to have a bad time. One of the things that we've noticed in the last 3 or 4 months is it's not just pen testers and researchers looking at this stuff. Bad guys have worked out what Kubernetes looks like and how it works. So there was a good story from someone who put a cluster online in AWS and they didn't authenticate the kubelet, and they came back within a day and found Monero mining on their cluster. So because the kubelet's cluster admin access, right? Bad guys have worked out import scan for 1080, do mass scan, 10250, find access to it, and there's free Monero mining. And the whole point of Kubernetes is it lets you run up new containers, so it can run up new workloads. Then clusters can be quite big, so you can run up lots of new workers to do whatever it is you're trying to do. So we're starting to see real live attacks. Tesla also got hacked. They did something really dumb and actually put their API server online without authentication, and that didn't end very well for them. They got Monero mining as well because it's 2018 and you've got to mine Monero. That demo worked. Okay, other means of acquiring access, and this kind of goes to what Paco was saying in his keynote this morning. People put things in GitHub that they shouldn't. This one is an example. That's just the way you authenticate to Kubernetes usually as a user is use a thing called a kubeconfig file. And I just searched for things that you would find in a kubeconfig file on GitHub. And I got 200 hits. Now again, I'm a white hat. I didn't go try any of those, but the black hats absolutely are going to as Kubernetes gets more popular. It tends to be files that give you access to these things. And the keys are stored in files. And files get committed to GitHub. One of the assignments that we've started to see being asked for by customers is they'll say, here is our private GitHub repos. Can you make sure that none of the information that's in there, A, there shouldn't be any secrets in there, and there always are, but B, make sure that none of our developers, because what a developer will do is they'll get a private GitHub repo, they'll fork it to do some work on it. They'll think, oh, I don't want to commit that back to the mainline yet, I'll just put it up in my own personal account. Personal account's not private anymore. If there's secrets in there, and they might not even realize there's a secret in there, right? Because it's in some file they don't look at. And suddenly you've punted a secret. And whilst AWS and GitHub will look for AWS keys, there's loads of other secrets like this, like SSH keys, and they'll find their way into GitHub. So it's very much, that's another way that people are going to get access. Attack the OS kernel. This one gets a bit overplayed. Containers actually have a reasonable level of isolation from the underlying operating system if they've been configured right. If someone hasn't been right. But you might be able to get it. If there's a new kernel vulnerability, there's possibility for attacks. Leveraging access in the cloud. So this is the other thing which is kind of interesting. Like I said, everyone's deploying the stuff in Azure now. They're deploying AWS. They're deploying it in GCP. That can have consequences where an attacker doesn't just compromise your cluster, but they compromise your cloud account. Because the way it works is that if you deploy your cluster in, for example, it's AWS. I'm going to do this one as a video because I'm not dumb enough to try a demo that relies on internet working. So let's full screen this. Okay, so I've got a cluster running in AWS. And I'm going to say what could happen if I got access to one of the containers. So I'm just going to attach to a container that's running in the cluster. And that's all that does. And then it gives me access. And then I'm going to try this. Now, I'll pause there just so I can talk about it. There's a cool thing in AWS land called the metadata service. The metadata service is on a predictable URL. It's always 169.254, 169.254. And every EC2 instance in an AWS environment gets some credentials given to it, which are decided when they get rolled up. And turns out some of the Kubernetes deployers that deploy to AWS give a lot of rights to the EC2 instances. So if I get into one container, as far as AWS is concerned, that container is just running on that EC2 instance, and it's the same as the EC2 instance. So if it says, hey, can I have my credentials, please, because I want to do something, Amazon will say, yeah, sure, here, have your credentials. You can do whatever you want. So here, all you need to do, this one, I've just said, okay, go and get me those, the security credentials for this node. And you can get those just by browsing around the metadata service. So if you've got access to a single container, you can basically just do that and say, hey, go to this, yeah, and I'm going to go and get the security credentials for the node. And then what you do is you hit enter, and it does that. And that's basically a set of AWS credentials. Depending on how much access that account has been given, that could be as bad as allowing me to spin up an unlimited number of instances. It could be as bad as allowing me to go and access everything else in that AWS account. So your AWS rights are critically important. And this comes down to secure defaults again. So some of the deployers for Kubernetes, a couple of versions ago, they gave you almost full rights to the AWS account. So if an attacker went into one container, they could then use that container to take over the full AWS account, which is going to give someone a really bad day until they get that nasty billing alert that says, hey, you've got a whole load of money in Monero mining, why did you do that? Or you get an alert from the AWS ops guy saying, hey, you really didn't want to do that. But yeah, that's why, and we're seeing, as I said, we're seeing lots of people deploying in the cloud. It's pretty much the default deploy mechanism now. So this is a problem. Malicious users. Malicious users are really hard to stop. So you can, if you let people run containers, so say I've got like 100 developers, I've got a cluster, I don't want them all to necessarily be cluster admin. It's quite easy to try and get access once you're a privileged user. So if I do a very, very quick demo, how am I doing for time? Ooh, okay. It will be a very quick demo. Great. What I'm going to do is I'm going to create a thing called privpod. And what privpod has, if I've got it here, privilege, so, where am I? Here we go. There's a concept in container land, and it's a really dumb concept, but people like it and they use it for things, called a privileged container. And if a privileged container basically says, turn off all the isolation, turn off all the security features of this container, and give me essentially full rights to the underlying host. Some containers need this because of what they do, because they actually do something to the underlying host. So as a result, every Kubernetes install I've ever seen has this turned on as a possibility, so it allows it as a possible. So if you've got a user who's malicious, or who maybe wants to do something they shouldn't, they can just do that, and then you can say kubectl exec-IT pod. Helps if I have a minus in front of my IT. Okay, and then you can just say mount. Where am I? Oh yeah, I did it. I put it inside the thing, didn't I? What I've done is with this container, I've just mounted the root file system from the node inside /node. And if you look at who I am, I'm root. So I'm root, and that's the root file system of the underlying operating system. So if I had the right to create that pod, I've got the right to mount that file system. And then I can just say, hey, I can just go and read out the keys, I can go read out tokens, go and read out whatever else, other secrets there are inside the node. I can add a new user by modifying the etc password and shadow files. Basically, if you let people do that, it's kind of difficult to stop them getting access. There are ways of doing it, though. But that's just the sort of problem you're going to have if you've got users doing that sort of stuff. Demo worked. Yeah, access to nodes is bad. Nodes have to have rights to talk to the API server, because obviously they need to communicate with each other. So if someone gets privileged access to the node, it's probably going to be bad. It's possible, but difficult to restrict that. Okay, so key security considerations. Cool. This is what you need to do to fix this stuff, right? This is the basics. These aren't everything, but this is the basics of getting this stuff right. The clue is in the name. Turn the insecure port off. Yeah, 0 and just have the bind address to not set. You can turn it off in configuration, but it's absolutely worth doing. API server authentication. Authentication in Kubernetes land is a bit weird. It used to be they used like a basic auth file, which put the credentials in the clear on the API server, which is bad. Obviously, any security person will tell you don't put credentials in the clear. They then went to having a token file, which was just tokens, but again, it was static. If you wanted to add a user, you had to go and reboot the server or reboot the service, which was painful. So then they went to using client certificate authentication, which is a lot of what's done now. The problem with that is there's no way to expire a certificate. So if you issue a certificate and then it gets stolen or lost, you have to rebuild the entire certificate authority, which is really painful. If anyone's ever done that, it's not a fun thing to have to do. So it's not fun. So the answer is now what they do is they support external authentication mechanisms, so OpenID, things like that. And the recommendation is go and use OpenID or something like that. Do not try and use the inbuilt mechanisms because they're not a good idea. Enable RBAC. RBAC, and this watch for this. If you're deploying Kubernetes, watch for this because not everyone does it because it's a bit complicated. RBAC essentially is the difference between having every single person being an admin and having only some people be admins. If you don't enable this, every single person is an admin. Better, more modern distributions will generally put it on by default, but not every single one will. I've definitely seen ones that don't. Control access to the kubelet. Yeah, don't let people have unauthenticated access to your kubelet because they'll take control of your cluster. You can do it. It's all just configuration options. There's nothing too radical. Control access to etcd. Yeah, so it uses client certificate authentication. The only thing I'd say is be a bit careful. The way it works is it basically says any certificate issued by my trusted CA is good and can have full access. So if you use the same certificate authority for like 5 different things, anyone who gets a certificate for any of those can go and do that, point to your etcd server and say, hey, give me access. So you kind of need to have its own little personal CA. Other things to think about. Pod security policy. They now have a great thing that stops me. That thing I did where I said privileged, you can put in a policy that says no one's allowed to do that, or only certain people are allowed to do that. But you absolutely need to. If you've got users you don't necessarily want to be cluster admin, you've got to have a pod security policy. Otherwise, they can just go, hey, give me privileged access. Security context. You can lock these things down. You can lock containers down from what the defaults are if you add a security context. So you can restrict their access to do things, and you should. And network policy, they have a little firewalling, fairly new feature, but they have a way of actually saying firewalling all your containers off. So you can say, hey, containers, you have no need to go and talk to the control plane. Why are you talking to the kubelet? Why are you talking to etcd? Let's put a little access control list in place to stop you. There are some resources. There are actually lots more. These are some of these are some. The CIS standard is well worth looking at. Do not try and, it's 200 and something odd pages long. Don't try and do everything it says. Because you'll break your cluster. We basically went through every single option in Kubernetes land that could have something to do with security and said this is a secure version of it. So you have to look at it and say, how does this apply to my environment? But it's a very good starting point because it does contain information about every single security option in Kubernetes. And if you want to have something which just analyzes your cluster for you, try this out. This is my one. There are other scanners. That's my one. It's pretty beta, but it shouldn't break anything, I don't think. And it does. Hold on, it does give you it gives you a shiny report. So it basically just says, what did you pass and what did you fail? So it's kind of useful for that. Actually, that's a slightly old version. I've got a new version with shiny graphs as well. But basically it gives you pass, fail, and you can have a look at it. It's kind of an easy way, instead of doing it all manually, it does some of the stuff for you, because it is boring to go and do it all manually, which is why I created it. Conclusion. The security model of Kubernetes, you can fairly obviously say, definitely in the early days, it was not perfect. It's not what I would call great, but it is getting better. The KubeCon that I just went to, they had a whole track of security talks, and they actually had some security stuff in the keynotes, so it's kind of nice to see they're obviously paying a bit more attention to this stuff. The default security options are extremely important. If you want to use this product, and you will encounter it. If you go in, I don't see this stuff going away, so you probably will come across it. And basically the defaults are the most important piece, because once this stuff's up and running, it's very complicated. People aren't going to go back and change anything. And think about your threat model and attack surface. If you need to worry about malicious users, then there's more you need to do. If you need to worry about malicious containers, there's more you need to do. Questions? Anybody questions? Yes?
The AWS keys that you popped up earlier, I take it you changed them.
Luckily, they expire. Very handily, they expire. I did check that. So those expired back in February. And also, I spun down the cluster because one of the things, I don't work for a cloud company, so I don't have a magic cloud account that doesn't charge me. I once left a cluster running over a weekend because I was testing something. 60 quid bill. One weekend. I just forgot because I was waiting to respond to someone. I'll leave that cluster running. I'll come back to it. And then I got the bill at the end of the month. I was like, won't make that mistake again. Yeah, so unless you work for a cloud company, you're always really careful to spin down your instances. So yeah, they were gone.
No free Monero for me.
No free Monero. Not from my bill, God, no. Yeah, right at the back.
In terms of all the different distributions of Kubernetes, which ones are the worst offenders that we should avoid?
Oh yeah, so the question is, which are the worst offenders in terms of distributions? Can I flip that around and give you the ones that are actually better? Because there's a couple that I should be able to talk about, but it's still, I'm probably not allowed to. The one I would look at in terms of if you want to roll this stuff out and you want it to be good out of the box, they're very opinionated, but the Red Hat stuff, Red Hat OpenShift, they absolutely take security quite seriously and they set a lot of stuff up right by default. So they're definitely one to look at. Any of the more community distribution ones, be a bit careful. Anything that says it's not for production use, absolutely avoid, because they definitely won't have said it. Even some of the ones that do, it's worth checking defaults, but a good one, if you want to pick a good one, or Google Container Engine, that's the other one. Google essentially they started this project, so guess what, they're quite good at hardening it down. So you'll have a reasonable time on if you're a kind of Google Cloud person, but OpenShift is good as well. So, yeah.
How did you break through the initial sort of barrier of domain knowledge for Kubernetes?
Yeah.
There's a lot of
There's
terms that it uses that you just
yeah.
don't understand.
It is really, really, and actually it's a good point because they're making it more complicated every month. They keep coming up with something new, so it is quite difficult. What I did was I just got actually one of the good ones is a thing called Kubernetes, the question is how do you get around the domain knowledge of Kubernetes, how do you learn the terms? There are some good resources. I found that just installing clusters repeatedly helped. There's a thing called Kubernetes the hard way. So there's a guy called Kelsey Heiter. Kelsey Heiter has tons of really cool stuff. One of the things is this thing called Kubernetes the hard way, which basically has you build a cluster doing all manually, so no installer scripts. So you do everything yourself, you set the etcd up yourself, you set the API server up it's slow, obviously, and it's just learning it. I wouldn't ever use it for production, but it's a good way of like going, hey, that connects to this, and that's why that's not working. That, and there are some good books. There's a Manning book called Kubernetes in Action, which I like. That was a good one. The only problem I'll say about books in this topic is they get out of date really quickly. So literally, you buy a book that's taken 6 months to write, so that's 2 versions ago by default. So you have to be a bit careful with what it'll tell you, but at least it gives you the basics. But yeah, things like Kubernetes in Action, Kubernetes Up and Running, which is the early one, that, and I follow lots of people on Twitter. There's the other one. There's like a load of these people on Twitter. There's just too much information now. KubeCon had, I think, 10 plus tracks, 3 days. So you could spend like a whole month, literally, just watching the talks from KubeCon. But yeah, that's how I did it. I just kind of repeatedly installed stuff and see what broke. Anyone else? Oh, coming in, yep.
Are there any major differences in security considerations for on-premise like Rory Kubernetes as opposed to the managed ones from AWS?
Okay. Good question. Right, the question is, are there any differences between the managed Kubernetes install options and the on-premises roll your own? The answer is yes. There's an upside and downside to managed. The upside is they do some stuff for you, so you don't have to worry about it. The downside is you're constrained by their idea of what is available. So in general, they'll control the API server, so you can't change the configuration of the API server. So a good example is that on AKS, which is Microsoft's one, right now it's not quite general availability, and they don't support RBAC, right? So you can't have RBAC on your AKS cluster right now until they implement it. On Google Cloud Container Engine, you don't get network policy by default, so you can't deploy network policy. I think there's a feature flag for that one, but it's not in the default install. So on the one hand, you don't have to worry that they've made some really boneheaded error and left something wide open. On the other hand, if they don't implement it, you can't have it. So it's that kind of like, if you want super, super secure, you probably want to do it yourself. If you just want super easy and not horribly insecure, they're a good option. And also, you're happy to pay the money that they charge because they're not free. Yeah.
When you're using Kubernetes, what do you find is different compared to using Docker Swarm or Docker Services?
Yeah. So the question there is between the difference between Docker Swarm and Docker Services and Kubernetes. What I would say I like Swarm, right? It's not done very well in the marketplace. Docker Swarm essentially is Docker's container clustering. It's incredibly simple to get working, right? You basically, it's like 2 commands and the whole thing just spins up, manages itself. And from a security standpoint, it's actually quite good. It doesn't have all these ports and services running. There's not a lot to attack, and they've got the defaults quite good. So from that perspective, I like it. However, if we're realistic in the marketplace, even Docker have recognized they're not winning this one. Docker themselves now support Kubernetes on their managed platforms, so they've kind of recognized that Kubernetes is kind of winning the war, if I call it that. The other anecdote I'd say is that I've heard from some people running Docker Swarm in production that there can be some stability issues. I think maybe that's biting them a little bit. But in my personal opinion, Docker Swarm is nice. If you want to try and get like a small cluster of containers running, I would try Swarm out because it's really easy. And only then if it doesn't do what you want it to. And it doesn't have all the kind of products coming up around it that Kubernetes seems to have. If you want all that stuff, and also where the kind of ball seems to be going, Kubernetes is a more popular option. But definitely, yeah, way more complex. Cool. Anyone else? If not, then thanks very much.